notice, and this is the typical copyright. We continue with the syllabus for mathematics, Caribbean Secondary Education Certificate, which became effective in May-June 2018. This syllabus has not been revised, but there are plans to change the structure of the exam from 2028 moving forward, with a few pilot projects now being conducted in a few Caribbean countries. The two main plan changes are: one, split the exam into two parts, maybe two levels, and secondly, there will no longer be any alternative sections. All sections will be tested. Schedule of videos, as you already know, these first three sections here, all 51 of those videos have been published on YouTube in their entirety. Please make good use of them. From section 4, measurement, 5 of those 17 videos have been published on YouTube in their entirety. Section 5, statistics, 5 of those out of 18 have been published in their entirety on YouTube. Section 6, algebra, 7 of these have been published on YouTube in their entirety. That's 7 out of 22. We are now at section 7, relations, functions, and graphs. This is the 11th of 26 videos, and I am aiming to finish this section by the end of this month, February 2026. After that, we will continue with section 8, geometry and trigonometry. Hopefully by March 2026, that will be finished. And finally, section 9, vectors and matrices, by April, May 2026. Please note this disclaimer down here. This schedule is just a projection and is not to be interpreted as a contract with anybody. As I just pointed out from section 1, all 33 of these videos have been published on YouTube in their entirety, especially since this section forms the foundation on which the rest of the syllabus is based. Another reminder, you need to know the times tables from 2 to 12, since calculators are not allowed in paper 1. That's the one with the multiple choice. Going back to the section 1, some of these videos are even applicable in primary school for students, for teachers, and for parents. As it relates to teachers, they can be used in the inverted classroom. As it relates to parents, parents could ask the children to look at the video and then explain back the video to them, the parents, and the students themselves can look at the videos before class, and to reinforce the concepts, to look at the same videos after class. For example, if you consider this blue box here, you will notice it says add, subtract, multiply, divide of whole numbers. That's video 6. But before you could add, subtract, multiply, or divide whole numbers, you have to know about place values, and that is an earlier video. And then it talks about addition, subtraction, multiplication, and division of decimals, and then addition and subtraction, this video here, of fractions, and the next video deals with multiplication and division of fractions. Sometimes children have difficulty with that, and the parents could have the child look at the video and then ask the child to explain it back to them, that is to the parents, and so on, order of operations, conversion of fractions to decimal and percentages, and so on. So it is applicable from grade 4, 5, and 6 in the primary school, and then on to the secondary school, grade 7, 8, 9, and so on. Section 2, consumer arithmetic. All 12 of these videos have been published on YouTube in their entirety, all 12. Section 3, sets. All 6 of these videos have been published on YouTube in their entirety. Section 4, These indicated in yellow have been published on YouTube in their entirety. The others are only partially published. If you want full access to those, please see directions in the description below. Section 5, Statistics. These indicated in yellow here have been published on YouTube in their entirety. The others are only partially published. Again, if you need full access to these that are only partially published, please see directions in the description below. Section 6, Algebra. These 7 videos have been published on YouTube in their entirety, especially since algebra seems to be a problem area for most learners. And then the others are published partially on YouTube. Again, if you would like full access to these videos that are only partially published on YouTube, please see directions in the description below. We are now at section 7, Relations, Functions, and Graphs. This section has 26 videos. Before we go on, recall I said in the introductory video that you will need a good math textbook or a set of 2 to get more practice questions. CSEC recommends these you see here on the right. Out of those, I would recommend these last 2 here, especially since they form a very good 2-volume set of math textbooks that is quite adequate for the current and the future proposed changes in the structure of the CSEC math exam. This is a picture of volume 1, and this is a picture of volume 2 here on the right. Please note this disclaimer down here. I get no financial or other benefits from the sale of these books. Also, as of late 2024, a website with AI interactivity has been made available free of cost that deals with past CSEC math questions only from paper 2. You can navigate by topics or years. And secondly, if you still have a question that you need explained, you can ask the AI assistant either by text or voice, and most likely that will be explained. It is extremely important that you become familiar with how CSEC sets its questions for paper 2 and what will be considered good or correct answers to such questions, and that is in relation to math. This is the URL for that website, and this is the home page for that website. Again, you will have to register first and then sign in subsequently, but remember I said it is free. This is the URL again up here. This URL will be in the description of this video below. A reminder that you will be provided with a formula sheet for the CSEC math examination papers. This is the formula sheet on the left here that you see. This sheet is included in the syllabus, but just in case you don't have a syllabus, there will be a link in the description below from where it can be downloaded. Here is the top part of that formula sheet so you could see it better. I will state the obvious. You do not need to memorize these formulae on this formula sheet, as this sheet, as I said before, will be provided during the examination. And this is the below part of that same formula sheet. While you do not need to memorize these formulae, you do need to know how and when to use them. Section 7, Relations, Functions, and Graph. We have completed these 5 objectives on this page. We have completed these other objectives on this page up to 9. As it relates to this page, we have completed objective 10, and we are now at objective 11. And we will return to that as soon as we finish taking an overview of where we need to go with this section. This is up to objective 17, up to objective 20, up to objective 22, and up to objective 26. That's as far as we are going in this section. Objective 26 will bring us to the end of section 7. So now that we had an overview of that, So far, we have completed up to video 10, objective 10. These have been published in their entirety. These others are only partially published. We are now here at video 11. When this is finished, it will be partially published as well. So the objective says, determine from coordinates on a line segment the magnitude or length and the midpoint. But you have to know what the concepts of midpoints and magnitude mean. And so once we know what those mean, we will then find the length and we will find the coordinates of the midpoint given 2 points on a line. So let's talk about the concept of magnitude or length and what do we mean by midpoint. Let's consider this line up here. Down here, this x-axis is measured in length in meters. Now let's consider these 2 points here, A and C. A is -4, 3, and C is 2, 3. How much linear space is there between A and C? From this point here to that, how much space is there? If we count them, or we can even calculate them, from -4 to +2, we have 6 meters. You can count them. 1, 2, 3, 4, 5, 6 meters. So you can see that there are 6 meters. That's a linear space between A and C. So we just subtract the x values. 2 minus -4. 2 minus -4. The y value does not come into play because the y value is the same throughout. So that is 6 meters. So we can say that the magnitude of the line segment AC is 6. In this case, we also have a unit, meters. But from here on, we will ignore the unit and just deal with the magnitude. We will call it length of the line. Now let's talk about the midpoint of AC. If you divide 6 into 2 equal parts, then each part is 3. If you start out at A and move 3 spaces towards C, so you start out at A, 1, 2, 3 spaces towards C, or if you start out at C and move 3 spaces towards A, start out at C, 1, 2, 3, you will arrive at the same point. We will call it M, which is -1, 3. The same point here, -1, 3. And that point B, well, the point M is called the midpoint of line segment AC. These two concepts, length and midpoint, are intuitive and therefore easy to understand. Now let's consider this line here on the right. This time it is not a horizontal line, it is a vertical line. How much linear space is there between R and T? From here, R, coming down here to T. How much linear space is there? Notice you are starting out at 6 and you are ending up at -4. So 6 minus -4, you get 10. So the length here is 10. We can say that the magnitude of the line segment RT is 10. Now, if we deal with midpoint, where is the midpoint between R and T? If you divide 10 into 2 equal parts, then each part is 5. So if you start out at R and move 5 spaces towards T, that will be 1, 2, 3, 4, 5 spaces towards T. Or if you start out at T and move 5 spaces towards R. 1, 2, 3, 4, 5. You will arrive at the same point M, which is 2, 1. The same point here, M, 2, 1. So that the point S, well, that is the point M, is called the midpoint of the line segment RT. These two concepts, as I said before, length and midpoint, are intuitive and therefore easy to understand. So we understand the concept of magnitude and midpoint. That was dealing with the concepts of magnitude or length and the midpoint of line segments. Now that we know that, let's do some calculation. So how do we calculate length?